So today's topic we are going to think about solid state. So we will try to conclude almost important topics in solid state. So solid state here we know that 7 crystal system is there. Before that we will try to see the packing fractions. So packing, how it is. Generally we have to remember CCP packing. It has alternative name as FCC. CCP means a cubic close packing or face-ended cubic close packing. In the case of CCP or FCCP, that packing arrangement is ABC. Okay, so 3 different layers will be there: A layer, then B layer, then C layer. Okay, so in ABC packing, we will be having both tetrahedral voids and octahedral voids. Okay, so tetrahedral voids will be always 2n. So n atom is there means 2n tetrahedral voids will be there and n octahedral voids will be there. So whatever the octahedral voids double to that tetrahedral voids will be there. So coordination number of CCP or FCCP packing is 12. So 12 is to 12 coordination number will be there. Okay, so first one is what is the packing arrangement CCP. Second one is how it is arranged, 3 layers ABC. What are the voids? We have 2n tetrahedral voids and 1 octahedral voids are there. So if you are thinking about examples for CCP or FCP arrangement is one example we can tell NaCl. This is a well-known example. We have to study its crystal structure, how it is behaving. So from here itself we can see. So for NaCl crystal structure, if they are asking, we can tell it has a CCP structure. It has ABC layer. It has 2n tetrahedral voids and n octahedral voids. Coordination number will be 12. So if you are thinking about coordination number 12, we have to see that in NaCl structure it will be 6:6. Means the CCP arrangement is chlorine. Chlorine will be in the ABC layer type arrangement. Sodium plus Na plus ions will be in the voids. Which voids it will be there? It will be in the octahedral voids. So this one also we can remember. So what is the structure of NaCl? If they are asking, we can tell that NaCl chlorine is arranging in cubic close packing arrangement or ABC arrangement, where we can get 2n tetrahedral voids and n octahedral voids. So in NaCl that coordination will be 6:6, means that octahedral voids of the n octahedral voids of the NaCl Cl minus cubic close packing structure will be occupied by cations Na plus. Okay, so now next example is which is under in the CCP arrangement is we can think about zinc sulfide in the blend form. Zinc sulfide in the blend form, if you are thinking, its arrangement is same way. If you are thinking zinc sulfide, that sulfur will be arranging as cubic close packing and it will be ABC arrangement. If it is there in the ABC arrangement, we will be having 2n tetrahedral voids and n octahedral voids. But zinc will be occupied in the half of the tetrahedral voids. Okay, so next we have to think about different crystal system. That is, we can think about fluoride crystal system CaF2. In the CaF2 also we can think that fluorine F minus is arranging in the CCP or FCC arrangement. So it has 3 layers, means ABC arrangement, and so hence we should have 2n tetrahedral voids and n octahedral voids, and cations is arranging in the all the 2n tetrahedral voids. Okay, so the packing efficiency of the CCP arrangement, will be 74%. So CCP arrangement we can think about 3 crystal systems: sodium chloride crystal system, zinc sulfide blend form of the crystal system, and CaF2 fluoride form of the crystal system. Okay, so next one is 2. Second one is hexagonal close packing. Hexagonal close packing is 2 layer system, means its arrangement will be AB. Okay, so in the AB arrangement, if you are thinking that coordination number will be 12. Okay, so if it is AB, only tetrahedral voids will be there. Okay, so only tetrahedral voids will be there. Example, we can tell nickel arsenic. NiAs. This is in hexagonal close packing. This is a well important question which can ask in multiple choice. NiAs in the hexagonal close packing arrangement. Another hexagonal close packing arrangement will be zinc sulfide in the woodside form. This is also important. Zinc sulfides in the woodside form is another tetrahedral arrangement, another hexagonal close packing arrangement. So hexagonal close packing arrangement will be having 2 and tetrahedral voids. So we can think that sulfur is arranging in the hexagonal close packing, means we have AB arrangement, and zinc is a cation and it will occupy in the half of the tetrahedral voids. Okay, so next one is third one is body-centered cubic close packing. In body-centered cubic close packing also the arrangement will be AB arrangement. Okay, so coordination number in this case will be 8. Example is CsCl, cesium chloride. Okay, so these are the important things. We can get a multiple choice question wise, it is very important. So if you are thinking one more time, we can cubic close packing arrangement. Examples are sodium chloride, zinc sulfide, calcium fluoride. In sodium chloride, chlorine is in this cubic close packing arrangement, so it will be having 2 tetrahedral voids and n octahedral voids. Coordination number is 6:6. So and cations means sodium plus ions will be occupying the octahedral voids. And next one is zinc sulfide blend form. Zinc sulfide blend form, sulfur is arranging in the cubic close packing arrangement, and half of the tetrahedral void is filled by zinc cations. And another one is calcium fluoride arrangement. It has 2 tetrahedral voids, means fluorine is arranging in the cubic close packing arrangement and it has 2 tetrahedral voids and n octahedral voids. Calcium is arranging, means cations is arranging in the tetrahedral voids arrangement. Next one is hexagonal close packing, which is AB arrangement, 2-layer arrangement. It is has 2 tetrahedral voids. Coordination number will be 12. Example is nickel arsenic crystals and zinc sulfide woodside form of the crystals. Another one is body-centered cubic close packing. Example is cesium chloride crystal. Least efficient packing is body-centered cubic close packing. Now we will think about crystal systems. If you think about crystal system, we have to remember in a particular way. Then it will be easy to remember. So if you are thinking crystal system, we have to think CRTHOMT. CRT HOMT. Here C means cubic, R means rhombohydral, T means triagonal, H means hexagonal, O means orthorhombic, M means monoclinic, T means triclinic. So this is in a particular arrangement I have studied, means CRT HOMT, HOMT. If you remember this crystal system in this way, it is easy to remember, because cubic means we will be having A equal to B equal to C, means all sides are equal. Rhombohedral also A equal to B equal to C. But when we are thinking about triagonal, it will be A equal to B not equal to C. Again hexagonal, A equal to B not equal to C. Orthorhombic, we will be having A not equal to B not equal to C. Monoclinic will be having A not equal to B not equal to C. And triclinic also will be having A not equal to B not equal to C. Means there is an order. First all are equal, then again one sided is not equal, then all the sides are not equal. Now if you are thinking about angle, there also an order. Order means alpha equal to beta equal to gamma equal to 90 degree in the cubic system. Means A equal to B equal to C, alpha equal to beta equal to gamma equal to 90 degree. When we do rhombohedral system, alpha equal to beta not equal to gamma. Okay, trigonal again alpha equal to beta equal to gamma equal to 90 degree. But in the hexagonal, alpha equal to beta equal to 90 degree and gamma equal to 120 degree. Okay, orthorhombic we will be having alpha equal to beta equal to gamma equal to 90 degree. But in the case of monoclinic, again alpha equal to beta equal to 90 degree, not equal to gamma. Okay, triclinic we will be having alpha not equal to beta not equal to gamma not equal to 90 degree. So if you are thinking there is an order, first alternatively angles are 90 degree. Okay, now if you are thinking alternatively two angles are equal, third angle is not equal. Two angles are equal, third angle is not equal. Two angles are here, all the angles are, two angles are equal, third angle is not equal. Here all the angles are not equal. Okay, so there is an order. So cubic, rhombohedral, triagonal, hexagonal, orthorhombic, monoclinic, triclinic means CRT formed. Now here another important thing we have to remember is that how many systems are there in each section. Means we have to remember like 3, 1, this we have to remember 2, 1, 4, 2, 1, 3, 1, 2, 1, 4, 2, 1, like a mobile number you can remember. 3 mane we will be having simple cubic, body centered and face centered. Means 3 systems will be there: simple, body centered, face centered. Okay, simple primitive structure, body centered structure, face centered structure. Another one is simple means rhombohedral. Again 2 means simple, body centered. 1 means simple. 4 means simple, body centered, face centered, end centered. Everything will be there. Simple, end centered. Then simple. So you have to remember such a way that we are getting first simple will be there, everything, simple primitive structure. Then if there is 3 means we have to incorporate body centered and face centered. 2 means next important, body centered. 4 means all the things, simple, body centered, face centered and end centered. Since end centered is incorporated, so simple and end centered. Okay, so these are the crystal system. So what are the examples in the crystal system? That when we see the crystal system examples, we first have seen CRT formed. C means cubic crystal system. In the cubic crystal system, we have seen 3 means simple, body centered and face centered. Examples, if you want to remember, means we have all the important examples are in cubic crystal system. For example, sodium chloride, KCl, CsCl, CaF2. Fluoride structure, sodium chloride structure, CsCl structure, all are in cubic crystal system. Another important example is diamond. Okay, so diamond also in cubic crystal system. Sodium chloride, CsCl, CaF2, calcium fluoride and KCl, all are in cubic crystal system. In the case of rhombohedral system, that there will be only one form, which is simple primitive forms. In the simple primitive form is there only for rhombohedral. Example, if you are seeing quartz crystals are in rhombohedral form, and calcite are all in the rhombohedral form. Okay, so when we think about trigonal crystal systems, trigonal crystal system has 2 forms, simple primitive and body centered form. It has oxides, sudden oxide, zinc oxide and TiO2. Zinc oxide and TiO2 are in the trigonal crystal system. In the case of hexagonal crystal system, we have one structure which is simple primitive. Examples, if you are seeing graphite. Graphite is a example for hexagonal crystal system, and zinc sulfide. Zinc sulfide is also an example for hexagonal crystal system. Orthorhombic crystal system, it has 4 forms: simple primitive, body centered, face centered, end centered. If you are thinking of these forms, that examples, if you are thinking rhombohedral sulfur as well as barium sulfate. These are the examples for the orthorhombic crystal system. Monoclinic crystal system has 2 forms, simple and end centered. Monoclinic crystal system has monoclinic sulfur, and we have calcium sulfate 2H2O, calcium sulfate 2H2O. Triclinic crystal system, if you are thinking, it has only one form, which is simple primitive forms, and examples are CuSO4 5H2O, CuSO4 5H2O, as well as potassium dichromate. Okay, so if you are thinking, all important crystals like sodium chloride, cesium chloride, KCl, CaF2, which we have studied briefly, are in the form of cubic crystal system. Diamond also in the cubic crystal system. Rhombohedral crystal system, if you are thinking, quartz and calcite are rhombohedral crystal system. Oxides are in the trigonal crystal system, zinc oxide and a titanium oxide. Graphite structure we have seen, it is in hexagonal form, we will write. So graphite will be in the hexagonal crystal system along with zinc sulfide. Orthorhombic crystal system means rhombohedral sulfurase. Monoclinic crystal system means monoclinic sulfur. And sulfate, among sulfate, orthorhombic crystal system is barium sulfate, but monoclinic crystal system is calcium sulfate 2H2O. Triclinic crystal system, there are copper sulfate, that blue crystals, copper sulfate 5H2O, as well as potassium dichromate, which is common in every chemistry laboratory. All these two are in the triclinic crystal system. Another important topic in solid state chemistry is radius ratio. If radius ratio between cations, radius of cation divided by radius of anion. We know in a solid state generally cation-anion interaction is more important, so cations and anions will be more in solid state. So radius of cations divided by radius of anions, that ratio, if it belongs to a certain level, then it belongs to certain category. So we will study in detail how it's finding. So if a radius of a cation and radius of an anion knowns, and if its ratio is between 0 to 1, then it belongs to linear category or linear structure. If it is between 1 to 2, 1 to 0.2, 0.1 to 0.1 to 0.2, then it is belong to triangular geometry. If this one is between 0.2 to 0.4, then it belongs to tetrahedral geometry. If it is between 0.4 to 0.7, then it belongs to hexagonal geometry. If it's between 0.7 with 1, less than 1, 0.7 and then less than 1. If it is in that, then it will become cubic geometry. So for 0 to 0.1 we have seen its linear structure and its coordination arrangements will be 2. If it is between 0.1 to 0.2, if it is triangular planar and its coordination arrangement will be 3. 0.2 to 0.4, it is tetrahedral geometry and its coordination arrangement will be 4. 0.4 to 0.7, it is hexagonal geometry, or we can tell octahedral geometry, then its coordination arrangement will be 6. 0.7 to 1, if it will be cubic geometry and its coordination arrangement will be 8. So let's see its examples. If it is above 1, then we can tell that it is close packing arrangement, and generally metals will show the close packing arrangement. Its coordination arrangement will be 12, means it can become face-ended cubic close packing or hexagonal cubic close packing, FCC or HCP. So in both cases it can become FCC or HCP, but in both cases its coordination arrangement will be 12. Generally metals will show this type of arrangements. So metals, we know that cations and anions both are similar, both are same metal, so that ratio will be 1 and its coordination arrangement will be 12. Examples will be generally metal. Let's see if it is become 0.7 to 1. Its cubic arrangement, its coordination arrangement number will be 8, and examples will be, example is CsCl, cesium chloride. In the case of 0.4 to 0.7, its octahedral geometry, coordination arrangement is 6, example is sodium chloride. 0.2 to 0.4 tetrahedral geometry, coordination arrangement is 4, and example is zinc sulfide. If it is 0.1 to 0.2 triangular geometry, its coordination arrangement is 3, example is boron oxide. Okay, so these are the example. For for 1 metal, for 0.7 to 1 cesium chloride, for 0.4 to 0.7 sodium chloride, 0.2 to 0.4 we have zinc sulfide, 0.1 to 0.2 we have boron oxides.